So originally we had we're testing the coefficient of friction of a shoe on grass, but it's currently raining. The grass is wet. I didn't know if that had anything to do or mess up the testing, so change of plans. We're gonna do a shoe on carpet. So start by drawing a free body diagram. So we got a free body diagram, and we're testing the coefficient of friction. So you got to find the forces in every direction. So we start by finding the force of gravity. So you have the force of gravity, which you know is mass times acceleration. So we have a spring scale, and you test the force of gravity. We know it's about two and a half newtons. So we know the force of gravity is 2.5 newtons. And we know the acceleration is 9.81 because that's gravity. So if you take that, the shoe is about 0.25 kilograms, which would be about 250 grams. So we know, since we know the force of gravity, we know the normal force, because the normal force is the same as force of gravity in the opposite direction. So we know the normal force is 2.5 newtons. So we next need to find an applied force and force of friction. So we'll have applied force in this direction and the force of friction in the opposite direction. So that's our free body diagram to start off with. We're looking for the coefficient of friction, which is mu, or the mu of static friction. So mu is force of friction over normal force. So we have to do this for we'll do 3 trials. We'll do one with just the shoe on the carpet. The next trial we'll do the shoe with 200 grams added to it, and last we'll do the shoe with 500 grams added to it. So every time we have to calculate the normal force, which changes when you add weight. So we'll start off by doing just the shoe on carpet with no added weight. So what we do to test that is we take the spring scale and you put it to the shoe, and to find the force of friction of the carpet, it's the force that it takes to set the shoe in motion. So it's the force that you get right before the shoe is set in motion. So if we were to go like that and take it, so it's right there, right before it's set in motion, that's the data we need. So we'll get a close-up of that real quick. Alright, so that was the testing for just the shoe on carpet. Next we'll do 100 grams in the shoe, so we'll do that right now. So that was 100 grams in the shoe. Next we'll do 200 grams in the shoe. Alright, so that was 200 grams in the shoe. Our last and final test will be 500 grams or 0.5 kilograms in the shoe. Alright, so we tested 100 grams, 200 grams, and 500 grams in the shoe. So we calculated all the normal forces. The normal test with just the shoes, the first one, and then we have the 3 different weights. So it's the normal forces, and we just did the test to find out the friction force for the 3 with the weights and the normal one. And we're looking for the coefficient of friction again, and we know that mu is the friction force over the normal force. So all we have to do for each one is take the friction force and divide it by the normal force, and we have to do that for each one. So we're going to get 4 coefficient of friction, and that's all we got to do. We just got to calculate. Right, so we got all the friction forces, got all the normal forces, and all we had to do was divide the friction force by the normal force. I did that for each one of the tests we did. We had 4. So coefficient of friction for just the control, 1.2, and as we added weight, it was 1.1 for the 100 grams, 1.1 again for the 200 grams, and 1.1 again for our final test with 500 grams. So we finished up our experiment. I know you guys can't see this real well, it's backwards to you, but we We got our four things of data. So our conclusion is that even if you add weight, the coefficient of friction is always going to stay the same. You can see that our coefficient of friction results are pretty consistent with one another. And that makes sense because if you think the coefficient of friction is just a ratio, so to speak. So as the force of friction increases because you're adding weight, the force of friction should increase, but so does the normal force. So they're basically proportional to each other because as one increases, so does the other. So the ratio's always going to stay the same no matter what weight you add to it. So that's our conclusion to the experiment.